What is a database in brief? Now we know, database is collection of information stored in a computer. Different types of databases. Database technology has improved over the years. There are many types of databases, each have their own strength and weaknesses. Out of nearly a dozen types, to choose the best fit for your business, you need to understand each one of them. The following slides will list and describe the most common types in detail and with examples. List of types. Hierarchical database. Network database. Object-oriented database. Relational database. Cloud database. Centralized database. Distributed database. Operational database. NoSQL database. Personal database. Enterprise database. End-user database. Open source database. Data warehouses database. OLTP database. Multimodal database. Document/JSON database. Graph database. Time series database. Hierarchical database. The hierarchical database was developed in 1960s by IBM. The structure of a hierarchical database is like a family tree. A single parent object can have one or more child objects, and a child can have only one parent. With such a structure, hierarchical database offers high performance and query response time is quick. For your understanding, the window registry is one example of this system. IBM, Information Management System, is another example. Network databases. The network database also has a hierarchical structure but has some changes. The child can have more than one parent. It supports many-to-many or two-directional relationship. The data access is easier and flexible than the hierarchical model. The network model is conceptually simple and easy to design. Some examples of network databases are TurboImage, Integrated Data Store, IDS, RIMA Database Manager, UNIVAC DMS 1100, IDMS, Integrated Database Management System. Object-oriented database. The object-oriented database data is organized and represented as objects and classes. The object contains data and the procedures to operate this data. This means that object-oriented programming and the querying of data across complex relationships is fast and powerful. The code includes methods and procedures for reading and writing the data. These databases work well with object-oriented programming languages, such as C++ and Java. MongoDB Realm is one example of object-oriented database. Wakanda and Object Store are the other known examples. The benefits of UDBMS types are that it is very efficient to access and replicate data objects. Relational database. A relational database is the most popular choice and the most common type. Data is stored in tables. Each table represents a specific object like products, customers, orders, sales, and so on. Tables consists of rows and columns. Rows are used to populate data in tables. Relationships are a logical connections that is created by joining the tables based on various data points. This system is ideal for large projects and applications requiring frequent updates and information changes. You can access data in any order by using SQL statements. Relational database itself is a huge topic and cannot be fully discussed in one slide. We will have a separate tutorial for this. Following diagram explains how data is stored in relational database. Cloud database. A cloud database runs on the internet. This database is built and optimized for a virtualized environment. Of course, the data is stored on a local hard drive or a server, but the information is available online. A cloud is a virtual environment that can be either hybrid cloud, public cloud, or private cloud. Cloud databases can be used for a wide range of applications, including web and mobile applications, data warehousing, and more. As long as you have an internet connection, the data is available. To use a cloud database, users can either build an environment themselves, or pay for a service to store their data for them. All types of databases can be put into cloud. Security is a great concern for cloud databases, so encryption and other security measures are very essential part of the setup. All information needs to be protected well. Centralized database. As obvious from the name, centralized database is stored on a central server and can be accessed by multiple users over the network or internet. All users access the same set of data at one point of time. It provides data consistency and better management. Distributed database. In distributed databases, the data is spared and managed across multiple servers. Data is divided into small chunks and stored on multiple servers. This database is best fit for environments having offshore offices. Distributed databases provide increased speed, better reliability, and scalability. You have to bear the cost for extra manageability. OLTP database. OLTP database is used for day-to-day transactions. They feature huge number of short online transactions performing DML, which includes insert, update, and delete. OLTP systems generally deal with current state of data. Data operations can be accessed by simple queries. These systems serve large number of clerical operational users. Because of intensive use and multi-user support, they have to be available 24/7/365, with constant incremental backups. Data warehouse database. In a data warehouse database, data is collected from different sources into a central repository. This data, if further used for analysis to provide the business a meaningful business insight. These systems are optimized for fast retrieval of large amount of data and typically built using a separate set of technologies than OLTP systems. They serve a relatively low number of managerial users. Database technologies like Oracle, MS SQL, MySQL could be used to build a data warehouse, but there are special databases available to efficiently implement a data warehouse like Teradata, Amazon Redshift, etc. OLAP is one technology that analyze and evaluate data residing in a data warehouse. NoSQL database. NoSQL databases does not store data in tables. It is designed to handle large volumes of unstructured and semi-structured data. These databases emerged in 2020s when the cost of storage rapidly decreased. The term NoSQL originally referred to non-SQL, but lately not only SQL, since they have expanded to include a wide range of different database architectures and models. It is mostly used for real-time web applications because they are highly scalable and deliver zero downtime. MongoDB, CouchDB, Ryuk, Amazon SimpleDB are few examples. Open source database. An open source database is any database where the code is free to view, download, modify, redistribute, and reuse. Open source licenses allows the developers to build apps on existing database technology. Most of these open source store data in memory rather than disk to allow faster data access and retrieval. Some common examples of such databases are PostgreSQL, MongoDB, MariaDB, InfluxDB, and Apache CouchDB.